In mid-November 2025, an atmospheric river crashed into Southern California and dropped between 2 and 13 inches of rain in 4 days. By the time it cleared, Los Angeles had logged its wettest November in 40 years. There was just one problem. La Niña had just been declared. La Niña is supposed to leave Southern California parched. But that was not the strangest part. The strangest part came 3 months later, when scientists at the U.S. National Oceanic and Atmospheric Administration did something they had not done in 75 years. They retired the measurement system used to detect La Niña because the signal had grown so faint, so distorted by a warming ocean, that the instrument built to find it was no longer reliable. This is the story of the La Niña that broke the rulebook, and the scientists who had to write a new one. If you find stories like this one fascinating, moments where the science we trusted suddenly stops working, hit subscribe. This channel is built for exactly these turning points. Now let's get into it. To understand what just happened, you have to start with the system itself. The Pacific Ocean is the largest body of water on Earth. Stretched across its equator is a climate engine so powerful it can flood continents on one side of the planet, while drying out rainforests on the other. Scientists call it the El Niño Southern Oscillation, ENSO for short. Under normal conditions, easterly trade winds, winds blowing from east to west, push warm surface water across the Pacific from South America toward Asia. As that warm water moves west, cold water from the deep ocean rises along the coast of Peru to replace it. Every 2 to 7 years, that balance breaks. If the trade winds weaken and warm water pools back toward South America, the Pacific enters El Niño. If the trade winds strengthen and push even more warm water westward, exposing a vast tongue of cold, deep ocean off South America, the Pacific enters La Niña. To measure these flips, scientists watch a specific patch of ocean called the Niño 3.4 region. It sits in the central equatorial Pacific between 5 degrees north and 5 degrees south. When sea surface temperatures there drop more than half a degree Celsius below the long-term average and stay there for months, NOAA officially declares a La Niña. That half-degree threshold is not arbitrary. It is the line where the ocean change is strong enough to shift global atmospheric circulation. When it crosses, jet streams move. The Walker circulation, the giant atmospheric loop sitting over the tropical Pacific, intensifies, and the planet's rainfall map redraws itself. Indonesia and northern Australia drown in monsoon rain. Southern California, the Horn of Africa, and Central South America go dry. This is what La Niña is supposed to do. It is effectively Earth's natural air conditioner, and a strong one can drag global average temperatures down by roughly 1/10 to 2/10 of a degree Celsius. In 2025 and 2026, the system did almost none of that. The National Oceanic and Atmospheric Administration officially declared La Niña on October 9, 2025. It came months later than forecasters had originally expected. The Niño 3.4 temperature anomaly that month was minus 0.48 degrees Celsius. That was just barely under the threshold. By November, it had dipped to minus 0.68. By the second week of December, it was minus 0.7. Those numbers are technically La Niña. They are also barely La Niña. For comparison, the 2010 to 2011 event peaked below minus 1.5. It was more than twice as cold. Forecasters started calling this one La Niña Light. The World Meteorological Organization gave it just a 55% chance of persisting through February 2026. By early 2026, a burst of westerly winds in the equatorial Pacific was already tearing the pattern apart. Then the regional weather started. Misbehaving. In mid-November 2025, that atmospheric river hit Los Angeles. 2 weeks later, 3 more atmospheric rivers came ashore in California between December 20th and December 25th, dropping 10 to 20 inches of rain over the Sierra Nevada. La Niña was active. The textbook said drought. The reservoirs were filling. Across the Pacific, Australia experienced the inverse paradox. La Niña was supposed to bring cooler temperatures and above-average rain. Instead, Australia recorded one of the warmest October ocean temperatures in its history, while La Niña was actively forming. The seas around the continent were so warm they overwhelmed the cooling signal. And while California flooded, the rest of the southern United States, including Arizona, Texas, and Florida, were sliding into moderate to severe drought. The textbook La Niña pattern held in some places. It collapsed in others. From orbit, the picture looked correct. On the ground, it did not. Someone at NOAA had been raising this flag for years. Michelle Lahoureau is the lead Enso scientist at NOAA's Climate Prediction Center. She has spent more than 2 decades watching the Pacific flip, and her name appears on most of the agency's major Enso communications. When the 2025 to 2026 La Niña was finally declared, she gave a clear-eyed warning. There is a 3 out of 4 chance it will remain a weak event, she said. A weaker event tends to exert less influence on the global circulation, so it is possible there will be surprises ahead. What she was diagnosing was not just a weather forecast, it was a problem with the instrument. For decades, the official tool for tracking La Niña has been the Oceanic Nino Index, the ONI. The way it works is simple. You take the sea surface temperature in the Nino 3.4 region. You compare it to a 30-year average. The difference is your anomaly. That math worked beautifully for 50 years. It does not work as well anymore. The 30-year average is itself getting warmer, and fast. The Pacific Ocean is not the only thing that is heating up. The entire global tropical band from 20 degrees south to 20 degrees north has warmed substantially in the last several decades. So when the ONI compares the Nino 3.4 region to its own 30-year history, it is measuring against a baseline that has already shifted upward. The practical effect is twofold. The threshold for El Nino becomes too easy to cross. The threshold for La Niña becomes too hard to cross. The instrument starts mislabeling events. A genuine La Niña, where the atmosphere is responding to a cool central Pacific, can get classified as Enso neutral simply because the rest of the ocean has warmed faster than that one patch. By 2025, the gap between what the index said and what the atmosphere was doing had grown impossible to ignore. In February 2026, NOAA's Climate Prediction Center did something it had not done in 75 years. It officially retired the ONI as the primary tool for monitoring Enso and replaced it with a new index, the Relative Oceanic Nino Index, RONI. The math behind RONI is a small change with enormous consequences. Instead of comparing the Nino 3.4 region to its own 30-year history, RONI compares it to the entire global tropical belt at the same moment in time. It strips out the background warming. What is left is the part of the temperature signal that is actually driven by Enso dynamics, not by the planet getting hotter. When the National Oceanic and Atmospheric Administration reran historical events using the Relative Oceanic Nino Index, the rewrite was striking. An El Nino from 2023 to 2024, classified as moderate to strong. Under the old Oceanic Nino Index, came out about 0.6 degrees Celsius cooler, and it was measurably less significant than the original record had said. The 2020 to 2023 triple dip La Niña, which the old Oceanic Nino Index treated as 3 consecutive cold phases, was reclassified as one continuous, unbroken La Niña event lasting nearly 3 years under the relative oceanic Niño index. And the 2 winters that the old oceanic Niño index had called Enso neutral, 2024 to 2025 and 2025 to 2026, became definitive La Niñas under the relative oceanic Niño index. The signal was always there. The instrument just could not see it anymore. This is what makes the 2025 to 2026 La Niña historically significant. It is not the worst La Niña ever recorded, nor the longest, nor the strongest. It is the one that exposed the failure of a measurement system that had defined climate forecasting for 3/4 of a century. The signal was so degraded by background warming that NOAA had to build a new tool to detect it. It's a rare thing in science to watch a foundational instrument be retired in real time. Fixing the index solved one problem, but the second cause of La Niña's misbehavior is something a better thermometer can't help with. In February 2025, researchers at the Scripps Institution of Oceanography published a paper in Climate Dynamics with an unusually blunt title, Heresy in Enso Teleconnections. They analyzed 70 years of weather data, comparing what Enso predicted to what actually happened. They found that about 32% of Enso years are what they called heretical, meaning they openly defied the textbook patterns. And of those heretical years, roughly 70% were explained by a single thing: atmospheric rivers. Atmospheric rivers are long, narrow corridors of water vapor that funnel moisture from the tropics toward higher latitudes. The most famous one is the Pineapple Express, a moisture pipeline running from near Hawaii directly to the west coast of North America. When one makes landfall, it can dump a season's worth of rain in a few days. The November 2025 storm that flooded Los Angeles was an atmospheric river. The 3 storms that hit California in December 2025 were atmospheric rivers. The Scripps paper's key finding is unsettling. Enso doesn't control them. The big climate engine that's supposed to set California's seasonal rainfall has almost no authority over the specific storms that actually deliver it. California essentially won a series of atmospheric river lottery tickets in late 2025. La Niña was happening. It just didn't matter. The bigger system overrode it. This is the part forecasters are quietly worried about. Not that Enso has stopped working, but that Enso is being demoted from the master switch of the planet's climate to one voice in an increasingly loud room. For a California water manager watching reservoirs refill from atmospheric rivers, this is a story with a happy ending. For most of the planet, it isn't. In November 2025, researchers at the University of Texas at Austin published a study in AGU Advances using 2 decades of data from NASA's GRACE and GRACE follow-on satellites, spacecraft that measure water moving across the planet by detecting tiny changes in Earth's gravity. They found that Enso is the single largest driver of synchronized water extremes on Earth. When the Pacific flips, it can simultaneously cause floods in Brazil and droughts in the Horn of Africa. And they found something else. Before 2011, wet extremes dominated globally during Enso events. After 2012, dry extremes have taken over. The system isn't just becoming harder to predict. It's becoming harder in a specific direction, toward drought. For places that rely on La Niña rains, like East Africa and parts of the Indian subcontinent, a La Niña that fails to deliver isn't a curiosity, it's a food security crisis. Pastoralists in northern Kenya, farmers across the Sahel, and Australian growers all build their seasons around forecasts based on the old Enso playbook. When those forecasts stop matching reality, planning becomes guesswork. The same forecasters watching this La Niña collapse are watching the subsurface Pacific warm at a remarkable rate. NOAA and Australia's Bureau of Meteorology are now both projecting a potential flip toward El Niño by late 2026. If El Niño arrives as projected, 2027 will very likely set a new global temperature record. Not because of one event, but because of stacking. The baseline is already higher than it has ever been in the modern record. La Niña's modest cooling did almost nothing to reset it. And when El Niño releases its stored heat from the Western Pacific back into the atmosphere, it will be doing so on top of a climate that is already running hot. The whiplash is what concerns scientists most. California could go from a wet La Niña winter directly into an even wetter El Niño winter. Australia could go from a squashed La Niña straight into a severe El Niño drought. The system isn't oscillating gently anymore. It's snapping between extremes. What this La Niña has shown us is that the old climate rulebook is losing its predictive power. Enso is still Enso. The Pacific is still doing what the Pacific does. But the context around it, the warmer ocean, the wetter atmosphere, the rogue weather systems that don't answer to it, the very instruments built to measure it, has fundamentally changed the game. The good news is, the system that detected the failure is the same system fixing it. NOAA's switch to RONI is one of the fastest, cleanest pieces of operational science you'll ever see. A working measurement standard retired and replaced inside a year because the data demanded it. Satellites like Sentinel-6 measure sea surface height with centimeter precision. NASA's GRACE missions track water moving across the planet in near real time. Climate models that once gave us weeks of warning now give us months. But here's the metaphor I keep coming back to. La Niña and El Niño are the hands on the steering wheel of Earth's climate. Climate change is the foot on the gas. The car is going faster than it used to. The swerves are getting more violent, and the road ahead is one we have never driven before. We don't know exactly what comes next, but for the first time in history, we can see it coming. The instruments are sharper. The scientists are watching. And when an old tool stops working, they will build a new one, as they just did. The climate isn't going to start behaving by the old rules. The new rules are still being written. This is the climate we live in now. La Niña just showed us what that means.